So to look at the standard position of a vector, standard position. Now this is also sometimes called the component form, or sometimes it's called the position vector. It has a lot of different names, mainly because of different contexts. So the standard position, component form, or position vector. So what this all has to do with is that vectors are equivalent. Vectors are equivalent if they have the same magnitude, length, and direction. So whatever angle they're set at. Okay, so since this is true, it doesn't matter where they start. So when I want to have this, the standard position, or the component form, or the position vector, so what this is, it's the vector that starts at the origin. Starts at the origin and ends at the point AB. Okay, so since I can, it doesn't matter what the location is, as long as it has the same distance and direction, magnitude and direction, it can start anywhere. So to make things easier, I've put the start at the origin. So how this is denoted is AB with little, inequality signs, really, little sideways V's in between. Okay, so that shows vector AB, which makes it assume that I start at the origin and I'm ending right here at point AB, going in that direction. So then I can kind of pick out that this distance down here, A, is actually has a special name. It's called a horizontal component. And this distance B is called the vertical component. And if we were to show that that's the vector, this is the notation we would use. AB, vector AB. And then, so one more kind of definition with this. So if I wanted to, let's say I have 2 points. Let's say I have 2 different points. So to find the component form of vector AB, with A being x1, y1, and B being x2, y2. So if I have these 2 points, if I want to make it into what I'm defining here, starting at the origin, how I can find that is vector AB is equal to x2 minus x1, comma y2 minus y1 in these vector notation. Okay, so by doing this, turns it into the component form. So let's see how that can make sense with an example. So let's say for vector, I've got 2 points. E is -3, 2, and F is 2, 1. Okay, so we're going to find the component form of vector EF. And we're going to call it vector V. I'm bolding this V. We'll call it vector V. And then 2, after that, we'll go a little further with it. But let's kind of plot this first. -3, 2. So -3, 2 is right here. And then 2, 1 is right here. So here's, right now, EF. Okay, so if I find the component form, it's going to be the same distance in the same direction. So let's kind of just do that, starting at 0, 0. So it's still going to go in this direction, and it's going to be the same length. So it should be something like this. So let's see when I use that little formula, what happens. So if I do my x2 minus x1, 2 minus negative 3, comma, y2 minus y1, 1 minus 2. Then I'm going to get 5, negative 1. So let's see if that makes sense. 1, 2, 3, 4, 5, negative 1. So ending here at the point of 5, negative 1 is vector 5, negative 1. So in the vector notation, that means we started at 0, 0, and we go towards 5, negative 1. So this would be vector EF, or we'll call it vector V. Okay, so that's the component form. So now, let's go a little further and let's find the magnitude. Find the magnitude. So, to find the magnitude, this distance right here, let's kind of just set up a triangle. This would be 5 and negative 1. So, I'm going to use the Pythagorean theorem, which is just like the distance formula. It's just that now I don't need to do any subtraction of x and y values because I already did that. So, magnitude of vector v is the square root of 5 squared plus negative 1 squared. Our square root of 25 plus 1 is 26, which is approximately, let's see, it'd be 5.0 something. Just a little over 5. Let's say 5.1. 5.099. So about 5.1. So that makes sense. Vertical distance of 5, it's going to be just a little bigger than that. Okay, so that's my magnitude. And then the direction, if I set up tangent of theta, I'm trying to figure out what angle is this. So tangent of theta, let's figure out this angle right here, this reference angle, is opposite over adjacent, negative 1 over 5. So when I do tangent inverse of negative 1/5, I get a negative 11.3 degrees. Now typically though, we'd want to make it the positive version. So if we add 360 from that, or take 360 minus 11.3, we get 348.7. So between 0 and 360 would be a direction of 348.7.